Basically, we are looking at variation in sign of adjacent coefficient. For example, if we look at the following polynomial, say p of x, we have a 7-order polynomial equals 5 times x to the 7th power minus 3 x to the 5th power minus x to the 4th plus 2x squared plus x minus 3. Okay, so we are missing some terms. We are missing the 6th power, we are missing the 3rd power. But no matter, all we need to do is we are looking at where the two adjacent coefficients have opposite sign. For instance, we go from 5 to negative 3. 5 is positive, negative 3 is negative. So we have one change here. Okay, then we go from negative to negative, no change. But then we go from negative to positive. This is the second change. And then we go from positive to negative. So this one has 3 change. So this polynomial has total of 3 variation in sign. Okay, now where this lead us? Well, I told you we're going to discuss Descartes a little bit. Descartes, French Renaissance philosopher. Well, at that time, there was no distinction between mathematician and philosopher and physicist, and they all were philosophers. But he's known by his saying, "I think, therefore I am." If you learned that or you heard about this. Also, the coordinate system that we are using, the XY coordinate system, the rectangular coordinate system, we call them Cartesian coordinate system, as he is the one that started or showed the world how the usefulness of this system, where we pick up a point and we give the point the x value and the y value. But Descartes was mostly a philosopher. He was less mathematician. Another mathematician, and true mathematician at that time, well, not true, but tremendous mathematician at that time, he also did some other stuff, was Fermat. I think Fermat was a lawyer, or his daytime profession was the legal profession. But so he and Descartes were going back and forth. They were kind of bickering each other, competing. But Fermat was a much, much better mathematician. So whenever Descartes ran into a difficult mathematical question, he sent a letter, not an email at that time, but he sent a letter to Descartes and asked his advice on how to solve it. Descartes sent a letter to Fermat and ask him how to solve this and so forth. One time, Descartes came up into a problem, and he said, "This is impossible problem. I don't think that even Fermat can solve it." So he sent him this problem as a challenge, and you learn about this problem when you take next semester Calc 1. I'll show you the problem. And of course, Fermat solved it in no time, came back with a solution. The difference is Fermat knew calculus, or was helped developing calculus. Descartes was looking into calculus as a possible development of mathematics, but did not go deep enough to develop the understanding that we have. Matter of fact, French mathematicians make claim that Fermat should be considered one of the fathers of calculus. Unfortunately, we don't have a mother of calculus, although Sophie Germain later on became a great female figure in the development of mathematics, again in France. But she has to disguise herself as a man in order to be accepted at the school, at the university. And she published for a long time. She published as a man, and only later on she revealed her true gender. But normally we give credit for calculus. We give credit to Newton in England and Leibniz in Germany, and there is this debate who is really the father of calculus, and this debate is ongoing. I mean, it's still raging between mostly British and German mathematicians almost 400 years later, 350 years to be exact. But there is a claim for Fermat. So Descartes also plays a role in developing mathematics and did a little bit work in calculus. But this is what he says when it comes to our application. So this is a Descartes rule that has to do with variation in sign and zeros of rational, real zeros of polynomial. The rule, there are two parts to the rule. The first rule, I'm going to read it first and then write it. What Descartes observed is, he said that the number of positive real zeros of a polynomial is either equal to the number of variation in sign of the polynomial or less than this number by an even positive integer. For instance, if you have total of three variation, then you have either 3 positive zeros or 1 positive zero. Okay, that's the application. And also the second, number 2, will be a similar statement that tells us how many negative zeros we can expect. So let's write. The number of positive real zeros of P of x is either equal to the number of variation in sign or is less than this number by an even positive integer. So what about the negative zeros? How many negative zeros we have? I'll read it. I read the statement, then I write. And the statement goes like this. The number, it's pretty much following this statement, the number of negative real zeros of P of x is either equal to the number of variation in sign of P of negative x, guys. This is the difference. For negative zeros, we're looking at number of variation in sign of P of negative x. Or, again, less than this number by an even positive integer. So number 2. sorry, O is less than so let me correct myself here. Okay, so the number of negative real zeros of P of x is either equal to the number of variation in sign of P of negative x, okay, or is less than this number. Okay, what's given is P of x is 3x to the 6th plus 4x to the 5th plus 3x cubed minus x minus 3. Okay, and we need to find, you can guess, a number of positive 0 So let's check what is, how many variation we have for P of x. So part A. Okay, positive to positive, no. We have one here, and that's it. Just one variation, so the answer 1 positive 0. Part B. What do we need to do in part B? Remember, we need to look at the P of negative x. And this is the difference. So, P 3 of negative x to the 6th plus 4 of negative x to the 5th plus 3 of negative x cubed minus negative x minus 3. After reorganizing it, negative x to the 6th is positive. However, here, odd powers becomes negative. One more negative. And this becomes positive and negative. So now we're going to check how many variation in sign. 1 here, 2 here, and 3 here. There are 3. Okay, so the answer either 3 or 1 negative zeros. Okay, what come next and is what is the upper bound, what is the most positive 0 and what is the least positive 0? Because it's always even number less than 3. So it's, if it was 5, it would be either 5 or 3 or 1. Remember the statement? Okay, the statement less than this number by an even positive integer. So the smallest even positive integer is 2. Okay, I think I'm not going to start the next one, but the next one tells you something about what is the most positive value, what is the most negative value. We'll pick it up on Wednesday.